Hi, welcome to this recording for physical science. In this session, we're going to be talking about the first part of the electricity lesson, which is static electricity. You know that an atom is made up of neutrons, positive protons, and negative electrons. Atoms should have the same number of protons and electrons and be neutral. If an atom takes extra electrons, it becomes negative, so we say it has a negative charge. If it gives electrons away, it has more protons left than electrons, so it has become positive. We say it has a positive charge. Now, when an atom gains or loses electrons, it is actually no longer called an atom. It is called an ion. An ion can have a positive or negative charge. If it gained electrons and has a negative charge, it is called an anion. If it lost electrons and has a positive charge, it is called a cation. All amounts in physical science are measured with their own unit. We measure distance in meters, mass in grams, etc. The unit that we use for measuring the strength of an electric charge is called a coulomb. Electrons can be moved from one material to another and be stuck in one place, leaving one material with a positive charge and the other with a negative charge. This is called static electricity. The equal and opposite charges from static electricity will be formed at the same time. You can never form a positive charge somewhere without also forming a negative charge somewhere else. Now remember, charges that are the same repel each other. So in an object that has a negative charge caused by a lot of extra electrons, those electrons are all trying to escape. If the object touches a positive or neutral object, the electrons will be pushed to that object. But the protons that are trapped in the nucleus can never move. Only the electrons are free to move. If a negatively charged object comes in contact with a positively charged object, electrons flow until the charges are neutralized or equalized. If a negatively charged object comes in contact with a positively charged object, that's what happens. They'll flow until they're neutralized or equalized. So the electrons are what moves. And now they're going to be over here helping to cancel out this positively charged object. So you've got electrons and protons together over here, making less of an overall charge because they're canceling out those protons. And then over here, we had a lot of electrons, and now there's less. So there's less of a negative charge over here and less of a positive charge over here. So what do we mean when we say a charge is equalized? The negative charges flow until there is an equal amount of negative charges on both objects. Both will end up negatively charged, but with less charge than the original negatively charged object had. So in this example, both of them now have a charge. They have a weak negative charge. It used to be at the beginning of it that the cloud over here had a strong negative charge. Okay, it had negative 10, and the circle had 0, but now it's been evened out. So now they both have negative 5. So the word for that is equalized. So they both still have a charge, but it's less of an extreme difference than it was before. And remember, the protons can't move, so if a neutral object comes in contact with a positively charged object, electrons will flow out of the neutral object towards the positive object until the charges are equalized. So in this case, both will have a positive charge, but again, it's less of a charge than the original positively charged object. So the two of them now have a similar charge. So we again say they've been equalized. Bodies with the same type of charge push each other away. Bodies with different types of charges, where one is positive and one is negative, pull toward each other. We can measure how much force the bodies push and pull with using Coulomb's law. Coulomb's law is this equation. So we're finding the force. This is what we're looking for in the end. How much force is pulling between these two objects? And to find that, we take a constant, which would be given in the problem. They would tell you what number to put in for that, times all of this. So you take charge 1 minus charge 2. So you have two charges here. This could be Q1. And this positive one here could be Q2. So you'll know what the charges are for each of those. So charge 1 minus charge 2 divided by the distance between them. So R is the distance between the two of them. And we multiply that by the constant that they give us, and that tells us the force. An electrostatic field is an area of effect around an electric charge. This means that a charge can affect other objects without touching them. One way they do this is by inducing a charge. A negatively charged object will push away electrons in another object, making the second object have a positive area on one side and a negative area on the other. A positively charged object will pull on the electrons in another object with the same result. And again, the word for this is inducing a charge. So inducing is when they're not actually touching, but the electric field from this object over here is touching this object. So it's inducing a charge, and then what we've created is an induced positive charge on this side and an induced negative charge on this side. Conductors are materials that electrons flow through easily. Metals are all good conductors, and they all have a lot of free electrons to flow around. Materials that do not let electrons flow through them easily are called insulators. Insulators have a high resistance to the movement of the electrons, and they do not have a lot of free electrons. Static electricity can build up on one part of an insulator without spreading the charge through the whole thing. Neutralizing a charge is doing something to cancel the charges out to end up with the same number of protons and electrons. One common way to neutralize a charge is by grounding. Grounding is providing a path for charges to leave the body and go into the ground. This method is used to prevent charges from building up in the first place. So you might be familiar with the electricity in your house having a ground wire. A lot of things that you plug in have three metal prongs on the plug, and the bottom one, which is round, is the ground wire. And then what that does is goes directly to the ground. And it is used for this, to help prevent the charges from building up, so that if there are an excess of charges, they can escape right to the ground, and the ground can accept lots and lots of charges because it's really big. It's connected. It's the whole Earth. And the idea here is that this is neutralizing the charges. Okay, if the difference in charges is great enough, electrons can jump across the space between the charged objects, creating a spark. You see this when it's dark if you get a shock. You get that static electric shock. Maybe you scuff your socks on the floor, and then you go to touch a doorknob or a person, and you get that little shock, and you can actually see it if it's dark. And This is on a small scale, and then on a larger scale, this is actually what happens when lightning strikes. A charged cloud in the sky can induce a charge on the other clouds or buildings or the ground. Then electrons jump from one charged area to another. A capacitor is a device used to store charges in one place. A capacitor has two plates made of a conducting material and an insulator between them. The charges build up on one plate, but it can't be neutralized with the insulator in the way. If the insulator is removed or another path is provided, the charges can move across to the other conducting plate in an effort to neutralize the two plates. And that brings us to the end of this section, but if you have any questions, we encourage you to contact your instructor using one of these methods.